This instructional video is designed to show you how to find the quantum numbers that correspond to the last electron in an element. In order to do this properly, you will need, of course, the elements that you're given, which are listed here, but you'll also need a periodic table of the elements so that you can look and count things. So up first we have fluorine, and the first thing we want to do is determine an electron configuration. The noble gas core here is helium, and the rest of the occupancy is 2s2, 2p5. Once we've completed that step, the next is to write out the occupancy diagram. So we have 2s up, down, 2p, 3, minus 1, 0, and plus 1, 1, 2, 3, 4, 5. It's important to follow the rules for how we fill things in so that you can accurately determine which electron is the last one. It's this guy. So once we have that, we can read off our numbers. 2p tells me that n equals 2 and L equals 1. M sub L, we get that from the actual orbital, which is 0. And M sub S, we get that from the spin. Since it's down, it's negative 1/2. For Berkeley, we have to look on the periodic chart to locate it and then get the noble gas core, which is radon, and we write out the rest of the configuration. 7s2, 5f10. So we have the 7s, 1, 2, 1, 2, 3, 4, 5, 6, 7. For the 5f, minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. Altogether, that's 5f. And now we need to fill in 10 electrons. So 1, 2, 3, 4, 5, 6, 7. Spinning everything up. Once we run out of suborbits, then we can do the rest. 8, 9, 10. And because we've done that properly, we can now identify this one as the target and take the final step of writing out our quantum numbers. Because it's 5f, we know that n has to be 5, L has to be 3, M sub L, we can determine that from here, negative 1, and because it's a spin down, the spin quantum number is negative 1/2. Our last example is barium, and for that we need the configuration. So once again, you have to go to your periodic chart to get the noble gas core. That's xenon, 6s2, and 1, 2. So this is our last electron, and that means that we're going to have n equals 6, L equals 0. Our magnetic quantum number is 0, and our spin quantum number is negative 1/2. And so this is how you take the identity of an element, a periodic table, and determine what the 4 quantum numbers are for that final electron.